Math 110 workbook class. We're about starting. So we're given an assignment on Math 110 from our workbook. And the first question the lecturer asks us to solve is on page 2. Page 2, question 2. We're asked to classify these sets accordingly based on the available set notation in the right-hand column. Class, there are different methods of classifying sets. We have the roster method. The roster method, also known as the tabular method. Tabular what? Class. The roster or tabular method classifies sets in such a way that the members of the set are written out outrightly. The members of the set are written out what? Outrightly. We have the tabular or roster method. Class. Examples of tabular or roster method. If you have your manual, you see the E. If you have your manual with me, this is a tabular or roster method. Class, there is no stress in discovering the members of this approach, classification. But class, we have, so we call this roster form, but we have another form called the builder form. Set can also be classified in the builder what? Form. And then set can be classified in the statement form. So we have roster. In the roster form, the members of the set are listed out outrightly. In the builder form, you are given either a bit of algebra or something that you need to figure out before you discover the members. And the statement form, a statement is made that can help you discover the members of the set. For example, class, look at this. Vehicle brands in Nigeria is a statement form. Vehicle brands in what? In Nigeria. Names of local government area councils in Rivers State. That's a statement, right? From the statement, you can now discover the members of the set. But in the builder form, they don't give you the members of the set outrightly. They don't give you the members of the set what? Outrightly. So let us classify each of these sets. Either our answer will either be in roster, builder, or statement. Are we together? Roster, builder, or what? So class, with this explanation I'm giving to you, I want to see if you see that you can easily answer this. If you are not with your manual, you can snap someone's manual and so you can be following up. You have your phone. Just snap someone's manual beside you. It's good when you're seeing what they are solving. A. Vehicle brands in Nigeria. Class, which form is this? Statement, right? So class, the answer to this classification is what? Statement form. This set is in statement form. B, the one that says science, engineering, agriculture, and the continued education. Class, what set, what form is this? This is roster. This is what? Because last, there's nothing to find out here again. The members of the set have been given out outrightly. C, any real number divisible by 10. Any real number divisible by what? Class, what will you classify this? Any real number divisible by 10. You can say this is a builder form. This is what? Because class, you be the one to build the set, right? You now have to ask us anything that makes you start calculating. In the statement form, you don't need to calculate, you just need to list out. Statement form is very close to the roster form because it's almost like you know the answer, but they don't just want to mention it, but just give you one statement that will help you to figure out the answer. But class, this is not just a statement. This will require you to think of real numbers first. Require you to think of numbers that are divisible by 10. This is a two-step process of building the set. So we'll call this the builder form. D, a set of x, so that x is what? Z. This Z represents integer. A set of x, whereby x is an integer, Class, when you see this in set, it means is or is a member. X is a member of all integers. Z means integers. Z is a symbol for integers. And such that this symbol stands for such that X is greater than or equal to 0 and X is less than 10. This is clearly a set builder. This set class, this is a builder form because let us denote this set. In fact, let's denote these two sets, C and D. Let us build the members of this set. Because class, you could be asked to represent this set in roster form. In roster form means that you should list out the members. Let's find the members of these two sets. Set C, any real number divisible by 10. Divisible by what? Who are the real numbers that are divisible by 10? 1. They are just simply asking for the factors of 10. Factors of what? Numbers that 10 can divide them without any remainder. 1, 2, 5, and 10 itself. 10, 8. Class, these are the members of this set C. All these numbers are divisible by what? 10. Any real number divisible by 10 means that leaving no remainder. Leaving no remainder. Now, let's look at set D. Class, they do not ask us to list out the members. I'm just going ahead to do it. No, now, please. Set D, we have a set of X, so that X is a member of all integers. Class, integers can be positive, it can be negative. As long as you're a whole number, you're an integer. In mathematics, as long as you're a whole number, you could be positive, you could be negative. So minus 100 is an integer. Minus 200 is an integer. But once you are not a whole number, you're not an integer. It means decimals cannot be integers. Fractions cannot be. You must be a whole number. So class, X is all integers, but X must be greater than or equal to 0. And X must be less than 10. Greater than or equal to 0 means 0 is among. So this means that 0, 1, 2, till 9. Till what? These are the members of set D. So they do not ask you this, so I'm just trying to make you understand this the more. They do not ask for this. I'm just trying to make you understand the more. Class, the numbers of this set is 0, 1, 2, 3, 4, 5, 6, 7, 8. You stop at 9 because they say X must be less than 10. They do not say less than or equal to 10. Less than 10. Now, E. A-E-I-O-U. This a what? Roster, right? This roster, clearly. This roster form. Because we have to classify each of the sets into roster, statement, or builder form. F. Odd numbers divisible by 2 and 3. Odd numbers divisible by what? You have to build this set, right? What are the odd numbers that are divisible by 2 and 3? You have to ask yourself, what are odd numbers? And class, this set is very big. There's no limit. Odd numbers that are divisible by 2 and 3. There are a lot of odd numbers that are divisible by 2 and... Okay, let's not say there are a lot, but there are quite a few. 6 is divisible by 2 and 3. 6 can divide 2, can divide 3. 12. Odd numbers. Okay, odd number. 6 is not an odd number, it's true. Okay, they are not that much. Odd number. 6 is an even. What are odd numbers? That's this interesting question. What are odd numbers that are divisible by 2 and 3? 9 cannot divide 2. Don't be too fast to say empty set. Oh. It doesn't have any limit. That means even one big number above 100 can be there. You will not know. It's very rare to assume that there's no number that can divide 2 and 3. You say? 21. No. 21 cannot divide 2. Let's keep thinking. Yes. Don't say there's 42. 42. Odd numbers. Odd. Sorry. I retract my statement. Someone said 18. 18 is an even. Interesting. Class, this is therefore an empty set. Empty what? Why is something telling me that there might be a number? Odd. But it's going to be difficult. Okay, it's going to be difficult. You know why? There's no odd number that can divide 2. There's no odd number that can divide. Do you know that, right? that numbers that are divisible by 2 should be even. It's true, it's an empty set. You see? Set. Now let's go to G. It's a builder. You see, we have to build the set now. Are you not saying that you have to G 1, 2, 3 till 9. This one is what? Roster, right? Please snap someone's manual beside it so you can be following up what's going on. You will understand better if you are seeing what we are solving. You can use your phone. You have everybody has phone now. Just snap someone's manual beside you, even if you don't have your own manual. It will make it easier for you to correlate. There's a big difference between someone that is just following with blank head and someone that is using direction. Okay, so this is what they are doing. Okay, this is what they are. Snap someone's manual beside you. It's simple. Don't say I don't have manual. You now relax. Just snap someone's manual beside you. Let's look at I. State deputy governors in Nigeria. Statement, Abi. J. All prime numbers divisible by 2. Builder. All prime numbers divisible by 3. Builder form. What's the next assignment? What's the next assignment? Number what? Page 8. Where's page 8? Number what? Page 8, number 3. Page 8, number 3. Page 8, number what? 3. Follow me. No, nice. Page 8, number 3. I've answered it here now. Ask anybody around you. H-I-J. H is, if you have been following this, you shouldn't be asking me, self. State governors in Nigeria, statements. State deputy governors in Nigeria, statement. All prime numbers divisible by 2, builder. All prime numbers divisible by 3, builder form. The last 2 is builder, the other 2 is statements. Yes. I'm waiting for calculation here. Let's calculate now. Number 3 said, if a set of x such that, this symbol stand for what? X is greater than 5. And B is a set of x such that 7 is less than x, x less than 15. And C is a set of x such that x greater than or equal to what? 5. And D is a set of x such that 7 less than or equal to x, x less than or equal to 15. Interesting. Then we shall have to find A union B. A union. They ask us to find a lot of things. But class, before we start finding those things, let me bring out the real members of A to D. Let me bring out the real members of A to what? D. So it will help me to figure out what to do. A. X must be greater than set of A, X, so that X is greater than 5. Class. The set of A is all numbers from 6, 7 till infinity. Class, this is an infinite set. This is an infinite because an infinite set is a set that has no ending. Has no. That means you can keep going. There's what we call finite and infinite. Finite and this is an infinite set. Because class, there's no boundary at the other end, right? Yes, yes. I believe I saw when lecture teaching you inequalities, intervals. You know, you have open and close, right? Open and when you will draw your this thing like this. Is this one open or closed when you see this sign? This is open, right? But when I shade it, is what? I'll teach inequalities. Remind me, I'll teach inequalities in this class. I'm sure some of you may be lost in the lecture in this topic. I'll teach inequalities in this class and how to represent them on the graph, on the different types of inequalities and how to also represent them. Let's just finish this workbook. Now, class, A, this set A, set B. This one has a boundary. This is a finite set. So, 7 less than x means x greater than 7. Class, follow me. Follow me carefully. If they say 2 is less than 3, can we say 3 is greater than 2? Because this set has 2 statements. 7 is less than x and x is less than 15. Let's pick the first part of this set, 7 less than x. If 7 is less than x, does it mean that x is greater than 7, class? So we can say, because it's easier to understand numbers that are greater than 7 than to understand numbers that are less than x. Because we don't know who is x. We don't know who is. If you say, okay, 7 less than x. If you take this statement like this, who is x? No, you don't. So switch to the other side. If 7 is less than x, it means x is greater than It's easier to know numbers that are greater than 7, right? What are numbers that are greater than 7? 8, 9, right? But if I ask you what are numbers 7 less than x, tell me. You don't know who is x, right? So you cannot tell me the numbers that are 7 less than. So anytime you see a problem like this, switch it to the other side. If 7 is less than x, tell yourself, okay, it means that x is greater than. What I mean is if 2 is less than 3, it means you can say 3 is greater than 2. If 2 is less than 3, we can say 3 is greater than 2. So if 7 is less than x, it means x is greater than 7. Now, so x is greater than 7 but less than 15. But what? So we're looking for numbers that are greater than 7 but less than. So set B is 8, 9, 10, 11, 12, 13. Class, these are the set B. This set. Set C. X must be greater than or equal to 5. So starting from 5 to infinity. This is a finite set too. There is no ending of the set, right? All numbers that are greater than or equal to 5, they are much. And set D. Where's set D? Set D is almost like set B, just that now it's equal to here and equal to here. So 7 less than or equal to x, switch it just like we usually do. Switch it. If 7 is less than or equal to x, it means x is greater than or equal to. If 7 is less than or equal to x, it means x is greater than or equal to 7. But x must be less than or equal to 15. Now, because of the equal to there, 7 and 15 will be included this time around, right? So set D is what? 7, 8, 9, 10, 11, 12, 13, 14, 15. This is set D. Class, why is it important to bring out the members of the set before you start solving the main question? So that it will be easy. If they say A union B, you know who you are uniting with who, right? If they say intersection this, you know what to do. But if you have not brought out their members, it will be more difficult. It will be more what? Difficult. Those that are going, I believe it, maybe you have practicals, right? Hello? You have practicals now? Practicals. Don't worry, it's recorded. So you see the importance of making sure that you're on our registered members group class. The full class we did yesterday on Math 120 differentiation. Our students have it already. Those that have registered with us, we have a separate group apart from our general group. Apart from our general group, we have a separate. So those that have registered, we're able to have access to the class. Like they have practicals now, but because it's being recorded, they have the backup, right? So there's a reason why we are doing this recording. Don't think I'm enjoying it. It's stressful. But I have to do it because of everybody's schedule is not the same. Last example, we still have Math 110 tomorrow by 3 p.m. You might check now, some people are not even free tomorrow by that 3. They have practical or something. So you see, why this assignment is very long. So we'll do some today, we'll do some tomorrow. Anyone you miss, register with us so that you can have exclusive access to the class. Now class. So let's solve the first one. A union B. A union. A union B. When unifying two sets, it means join the members of the two sets together without repeating any of them, without any repetition. When unifying two sets, you are joining the members of this set to this set, but without any repetition. What do I mean by without any repetition? Class, set A, does set A have 9? Is there 9 in set A? Yes. Because set A is 6, 7, 8, 9 till infinity, right? Set B also has 9, right? So you want to join set A to set B, you will not mention 9 twice. Once you have mentioned 9, you have mentioned. So A union B start from set A, 6, 7, 8, 9, 10, 11, 12, 13, 14 till infinity. Till what? Why do we say till infinity? Because the set A is till infinity. So if you are joining a member of set A to B, you must mention the set members of A and all members of set. And members of set A can enter one bracket, right? Because 6, 7 till infinity. I hope I'm good there. So class, you say A union B, 6, 7, 8, 9, 10, 11, 12, 13, 14. Till is A union B. Is A union what? B. A intersection B, the second part of the question. Intersection means what is common between the two sets. What is common between the two? Class, what is common between the two sets? We start from this 8, 9, 10, 11, 12, 13. Because everybody in B is in A, right? But this 6 and 7 is not in B. Because B did not start from 6 and 7, it started from intersection between two sets are elements that are found in the both sets. Elements that are common in the both. So 8, 9, 10, 11, 12, 13, 14. Number 3, A minus B. Class, this difference between two sets. I've taught this if you were in my set class that time, January, I taught difference, right? I've taught difference between two sets, A minus B. What's another sign you can see if you don't want to use this sign? What other sign can they use? Slash, right? I've taught it in normal class before. I've actually finished set in this class, but I'll teach it again. Because when I did it then, we have not started recording, so I'll do it again so I can have the record of it. So those that are joining can still access the class. A minus B means subtract B from A class. Let me use a simpler example to explain it, class. So you also understand this. In fact, it's like I'm teaching set already now. I'm solving, I'm teaching, right? This manual also makes you know the topic because each topic in this manual is in your scheme of work normally, right? So you are learning. A, let's say set A is 2, 3, 5. I'm using a simpler example. And set B is 1, 2, 4. And someone says you find A minus B. Because the difference between two sets, you must recognize the primary set and the secondary set first. Because the primary set is the first set mentioned. Secondary set is the second set. Because class, you're going to subtract the set, all members of the secondary set from the primary set. When looking for A minus B, when looking for a difference between two sets, you will subtract members of the secondary set from the primary. And any member that still survives in the primary set is the final answer. When looking for a difference between two sets, recognize your primary and secondary set. First step. Who is the primary set? The first set mentioned in the question. Who is the secondary set? The second set mentioned. When looking for a difference between two sets, subtract the secondary set from the primary. Subtract the secondary set from the primary set. Now, it's every member of the secondary set that you find in the primary set, remove them. Then your final answer is the remaining members of the primary set only. Do not come and join these members of secondary set to it. So what is A minus B? Who is in B that is also in A? So remove 2 from A. And what's left? 3 and 5. So A minus B is 3 and... I'll come again one more time. The difference between two sets is subtraction of the secondary set from the primary. Subtraction of the secondary set from the primary set. Who is the secondary set? The second set mentioned. Who is the primary set? The first set mentioned. So you are removing every member of B from A. Remove every member of B from... Remove every member of B from A. So A minus B means remove every member of B that you can find in A. After doing that, what is left in A is your final. So let's come and apply that knowledge to our main assignment. This is just an example I gave. You see, I'm teaching, I'm solving. I'm teaching, I'm solving. Wherever I stop today, I'll continue tomorrow, 3 p.m. 3 will be here tomorrow. So we now have class on Wednesdays. We don't used to have class on Wednesday before. But we have class on Wednesday. This is exam period now. Now class, A minus B. A minus means subtract every member of B from A. Subtract every member of B from class. All these members of B are in A. Do you agree? Because A is 6, 7, 8, 9, 10, 11 till infinity, right? So A will cover every member of B. So class, we need to find a way to list members of A and subtract all these numbers from it. So A minus B will be 6, 7, 15 till infinity, right? 6, 7, 15 till... After removing every member of B from A, the members of A that still survive will now be the final answer. Will now be the final. Class, that's the difference between two sets. So we now have Math 120 twice a week, and we have Math 110 twice a week. So mathematics, we want to be seriously focusing on mathematics now because it's one of the courses that I know that those two maths, if not anything, just pass them once and for all. So yesterday we did Math 120. We still do Math 120 on Saturday. So Math 120 holds on Monday and Saturday. Math 110 holds on Tuesday and Wednesday. Chemistry also holds twice. We are offering chemistry. Chemistry holds on Thursday and Saturday. Thursday and Saturday. Then physics holds on Friday. Physics holds on. So that's our timetable. So we have class. That's the time table. So tomorrow is Math 110 again. We have 2 days Math 110, 2 days Math 120. Class, next question. A complement minus B, class. This CS stands for complete. Class, you cannot get complement of a set without first having a universal set. The funny thing is that they did not give us a universal, but interesting, I can teach you how to form your universal set if you are not given. Class, very simple. Your universal set is the chief superset of all the sets mentioned. Your universal set must contain every element in all the other sets mentioned. So, class, my universal set actually, when you're not given, class, your universal set is a union of all the sets listed. A union B, union C, union. Class, to get a universal set, unify all the elements of all the sets listed. To get your universal set, unify all elements of all the sets listed. So unify A to B to C to D. Unify A to B to C to D. So who is A? 6. I need a wider space to do this. So my universal set, let me do it here. Who is the smallest member? Is C, 5, right? My universal set must start from the 5 because C has 5, right? Then 6, 7, 8, 9. Now, because of A is still infinity, my universal set will also be T. Because by saying 5, when I start from 5, I picked every member of C, right? Because C is 5T infinity. C is 5T what? Infinity. D is 7. If you 7, 8, 9 to 15, it will still be inside here. Hope there's nobody we are missing out on. Everybody from A to D is inside this place, right? 5, 6, 7, 8, 9. Yes. Because your universal set must contain every element in all your sets listed. Having gotten your universal set, we can now go ahead to solve the main question, class. Class, we need to find A complement. Class, the complement of a set are members in the universal set that are not found in the set. The complement of a set are elements or members in the universal set that are not found in the set. The complement of a universal set are elements or members in the universal set that are not found in the class. What number is inside here that is not in A? Only 5. Only what? So A complement is 5. A complement is what? It's only 5 that is in U that is not inside A. Because A starts from 6 till infinity, remember? So everybody from 6 to the end is A. Only 5 is missing in A. Now, B, we already know B. Who is B? 8, 9, 10, 11, 12, 13, 14. Now, they say we should minus B from A because A complement minus B means, don't forget, when doing difference between two sets, recognize your primary set and your secondary. Who is the primary set? A complement. Who is secondary set? B. A complement is the primary set. B is secondary. So you are subtracting your secondary set from your primary. But is there a member of B that is inside A complement? So therefore, A complement minus B is an empty set, also called a null set or a void. Another name for empty set is null set or void. And how do you represent an empty set? You use an empty bracket or this symbol, class. This is another symbol for an empty set. You either draw an empty bracket or you do this symbol and slash it. You either draw an empty set or you do this symbol and do what? You draw a 0 and slash it. Class, elements or members of a set can also be called what? Exam, OBJ exam. Elements or members of a set can also be called dash. This is a theoretical question, no calculation. Elements or members of a set can also be called points of the set. Note, it's an past question. No? Points of the, everything is not calculation. You don't know, 2 marks has gone. Elements or members of the set can also be called what? Points. See, as simple as set is, nobody could answer. Points of a set. What year did this come out again? Points of a set. I remember when I was solving the past, I remember when I solved all our past questions. I remember solving something like this. Elements or members of a set are called points. Each question carries 2 marks. This 2 marks like this. No solving, no calculation. You don't know, you don't know. They ask them that which of the following is not a perfect number in your exam. There are some questions they ask in your exam that you will not see in any textbook. Which of the following is a perfect number? Which of the following is a what? First of all, you must know what is a perfect number. Have I taught perfect number in this class? I thought you have forgotten. I taught you types of numbers. January. Let me remind you. Perfect numbers are numbers whose factors sum up to give the same number. Perfect numbers are numbers whose factors sum up to give the class. What are the factors of 6? 1 can go in 6, right? 2 can go in 6. 3 can go in 6. Of course, 6 can also go in, but we don't mention 6. We don't mention 6. Class, the factors of 6 except 6 itself is 1, 2, and... Now, why is 6 perfect? Because if you add up the factors of 6, 1 plus 2 plus 3, you have 6. You have what? So this makes 6 a perfect number. This makes 6 a what? Another perfect number we have is 28. 28 is a perfect number because all the factors of 28, apart from 28, when you add them together, it gives you 28. Should we try it? Look at it. 1 can go in 28. 2 can go in 28. 4 can go in 28. 7 can go in 28. 14 can go in. Remember that 7 times 4 is 20. 14 times 2 is 20. 28 times 1 is 20. Add 1 plus 2 plus 4 plus 7 plus 14. You're going to have 28. Check your calculator. 1 plus 2 plus 4 plus 7 plus 14. You're going to have. Therefore, 28 is a perfect number. Therefore, 28 is a perfect number. If you are watching this video and you find out that we have stopped here now, note that the video continues after now, but if you have not registered, you'll be able to see the remaining part of this video. So if you want to join our class, send me a message so that we can register you for the online class. The video ends here for you, but the video continues. This is not the full video, but it ends here for you because you have not registered. So you can only see this part. So you want to register for the class, send me a DM. My number is there so that you can get the remaining part and pass your Math 110. So thank you very much. Now let's move forward. Because those that have not registered, this is where to stop. I'll cut it and send them this. Let them see. At least they deserve to see what they are registering for. That is the class. Then those that have registered now, I'll send them the full video on our paid members group. Yes, so they'll be the only one to be able to access it. So, very, very important. Very, very what? Now moving forward. And there's some classes I will not record at all. Like the shortcut class will not be on records. Because I just want only my students, my registered students. The day I'll fix shortcut class, I'm not going to record anything. So if you have not registered, you will not be part. And you cannot solve your mathematics long method from beginning to the end. It's not possible. You will not finish. It's me that's telling you. Even me, I will not finish. Me that know math, I will not. Why? Because let me tell you, the time is not usually enough. The time is not usually what? The time they give for math exam is just 90 minutes. And you have 35 questions. There's some questions that will take you 10 minutes to solve. You use long method. But they shortcut for it. There are questions that will take you 5 minutes to solve. You were in our math class yesterday, some of you, right? You saw some of the solving I did that they took a lot of time. If some of those questions come out like that for you in the exam, you find out that it will take so much time. But some of them have shortcuts. We're teaching you how to use your calculator to differentiate some questions without solving long method. Calculator can help you differentiate some questions. I will show you. Integration is the calculator can integrate. There's a part of your Math 110 where you will need to apply combination and permutation. Your calculator can do it. There's some parts of your what? Of your math that you need to apply what? Permutation and combination. And permutation and combination have a formula. Your calculator can do it. I'll teach you how to do it in your calculator. It's under binomial theorem. There's a formula under binomial theorem that enables you to what? To be able to apply principles of combination and permutation. A minus B. This time around, we're looking for B complements. First, before we now say A minus B. Who is B complement class? Have you started it? His mind is not still showing. It's showing now. B complement class are elements in the universe set that are not found in B. They are not found in what? Who are those here that are not here? 5, 6, 7, 15 till 15 till what? Okay. B complements. Elements that are here that are not, yes, till infinity, because this universe set is still, there are a lot of numbers till infinity that are here that are not in B, right? Elements that in universe set that are not in B are 5, 6, 7, and there's 8, 9, 10, 14, so 15 till infinity class. We now have B complement. Now what's A minus B complement? Remove everybody in B complement from A. Remove everybody in B complement from. Who are those in B complement that are in A? 6, 7. 6 what? 7. What will remain in A after removing 6 and 7? Everybody in B complement. What will be remaining will be in A, not in B, in A. So A minus B complement will be what's remaining after removing 6, 7. Also remove 15 because A is 6, 7, even 15 till in the end. What will be remaining is between 7 and 15. That is also in A. 8, 9, 10, 11, 12, 13, 14. Class, this is A minus B complements. I hope you get. Class, B complement is 5, 6, 7, 15 till infinity. 15 till what? But A is 6, 7, 8, 9, 10, 11, 12, 13, 14 till infinity. Till what? I want to show you something. Remember that this A, we're removing B complement from. So who are you removing from A now? B complement from A. Who are those in B complement that are in A? 6, 7. 6 what? 7. And A still contains 15 till infinity. Remember? 15 till, we're also going to remove it from A. What's going to survive this removal is from 8 to 14. 8 to what? Is what will remain after the removal. This A minus B complement. Now let's go to B complement minus A. B complement minus A. Well, this is B complement and this is A. This time around, B complement is the primary set, right? A is the secondary. This time around, I'm moving A from B complement. Every member in A, remove them from B. What will survive? Who will remain in from B's complement? 5. I think only 5. You are moving A from B complement. A from B. All members of A that are in B complement, remove it out. It's only 5 that will survive. Because 6 and 7 will go. From 15 till infinity will go because it's also in A. Only 5 will. So this is B complement minus A. Now the next one says C union D. C union D means unify every member of C with D. So start with 5, 6, 7. In fact, till infinity. C, because C is 5 to infinity. So whatever you add from D, is still going to end in infinity. Still going to end from which? So C union D is 5, 6, 7 till infinity. Next one says C intersection D. C intersection D is what's common between C and D. 7, 8, 9 till 15, right? 7, 8, 9 till 15 because everybody in D is in C, right? Because C starts from 5 till infinity. C starts from 5 till, when counting from 5 to infinity, you will meet 7, 8, 9, 10, 11, 12, 13, 14, 15. So everybody here is still here. So C intersection D, what's common between C and D is everybody. Now C minus D. That's different between C and D. C minus D. C minus D. Who is C? 5, 6 till infinity, right? And who is D? 7, 8, 9, 10, 11, 12, 13, 14. 7, 8, 9, 10, 11, 12, 13, 14. C minus D means remove D from C. C is primary set. D is secondary set. C is primary set. D is secondary set. C is primary. D is secondary. So you're moving D from C. If you remove everybody here from C, what will remain? 5 will still remain, right? 6 will still remain, right? Because this 5, there's 6 here, but there's no 6 here. 7, 8, 9, 10, 11, 12, 13, 14, 15 will go, right? And after that, 16 till the end will still remain. 16 till infinity will still remain. 16 till infinity will still do what? That's C minus D. Now, we have C complement minus D. C complement minus what? D. So we first have to go and find C complement. We first have to go and find C. I hope you are also following up as you are writing. Some people are in serious copying mode now. This test actually is good. You are taking it very serious because it's serious. If it was not serious, they were giving different ones to different odds. But I'm just finding out they gave the same as everybody should feel the same place in the workbook. I asked those in science, those in engineering, everybody they asked to feel the same thing. Meaning that all your different lecturers, because you have different lecturers in different odds now, decided to give the same assignment. So it's very serious. So this will be your CA format 110. 30 marks is at stake here. What is C complement? All elements in the universe set that are not in C. All elements in the universe set that are not in what? Who are those in I've cleaned the universe set, but you have it in your book. Who can help me? Who are those in universe set that are not in C? We're saying 5 now. 5 is in C. Those in U that are not here. Is it an empty set? Okay, that's true because C is 5 till infinity. And my universe set starts from 5 till infinity. So C complements an empty class. It means that an empty set minus anybody is an empty set. An empty set minus anybody is an empty. So C complement minus D is an empty set, is an empty. What of C minus D complements? Let's find D complement. Class, what members in the universe set are not in D? Members in the universe are not in D. 5, 6. They are not in D. 5, 6, 16 to infinity, right? 5, 6, 16 till this D complement. Now, what is C minus D complement? Remove everybody in D complement from C. What will be left? Between 7 to 15 will remain, right? Between 7 to 15 will still be remaining in C, right? So C minus D complement is 7, 8, 9, 10, 11, 12, 13, 14, 15. That's C minus D. That's C minus D complement. And the last one, C complement minus D. C complement, we have done that already now. Did they repeat it twice? They repeated it twice. So C complement minus D again is an empty set. It's an empty set. What's the next assignment? Please check your book. What's the next assignment? Page what? Page 11, number 2. Okay. Please write down this one. It's interesting too. Page 11, number 2. Math 110 assignment workbook. Math 110 assignment workbook. Math 110 assignment workbook. Page 11, number 2. Can I clean this? Can I clean this? Okay. You should have add this one since now. This one's on top. Page 11, number 2. medical center boasts of 15 pediatricians. A medical center boasts of 15 what? Pediatricians. P. In bracket what? P. 18 gynecologists. G. And 28 dentists. And 28 what? D. Out of these numbers, there are those who can do both pediatrics and gynecology. Out of these numbers, there are those who can do both pediatrics and gynecology. We call them PG. Gynecology and dentistry, GD. Pediatrics and dentistry, PD. And some that offer the three, PG, D. Like this will lead to a Venn diagram of three subsets. Venn diagram of what? This is one of the questions I said the reason why you can't finish in the exam. The questions they give you, some of them, so we'll give you a way of. Now look up. PG, they gave us as 10. GD, they gave us as 8. PD, they gave us as 6. PGD, they gave us as 3. They picked this information on a Venn diagram. We asked to depict this information on a what? Oh, that's all. Just depict on a Venn diagram. Ah, yeah, look, I thought they would ask you find how many students did PD only. Because class, a medical center boasts 15 pediatricians, 18 gynecologists, 20 dentists. In the Venn diagram, these three subsets. You will put the subset for P, pediatricians. The subset for G, gynecologist. And the third subset for D, dentists. Class, of course, this will still require you to solve. I just remember 15. These numbers here, you're not allowed to put them inside. They are not the correct numbers. Gynecologist 18. Dentist 20. The only correct number here is PGD, which is 3. Let me just inform you. To get those that are doing, let me tell you, in a class, when they say in a class of 100 students, in a class of how many students? In this question, they didn't even give you your universal set. And you cannot depict a Venn diagram without representing universal. So you need to go and get universal set. So how many people are in the medical center altogether? A medical center boasts of 15 pediatricians, 18 gynecologists, 28 dentists. What are total number of doctors in the medical center then? Is the universal set? We don't know. So by telling you to predict this in a Venn diagram, without mentioning universal set, your Venn diagram is not complete. It's not. Class, the only correct number here is this. Those doing pediatrician, gynecology, and dentist, 3 is the only correct number. Let me tell you something. Everybody in this class, let me tell you. Have you ever seen a set question when they would say there are 100 students in a class? 70 offer mathematics. 100 in a class, 50 offer physics. 60 offer chemistry. You will now be asking yourself, but there are only 100 now. If you add 70 plus 50 plus 60, it's over. But there are only 100. How come 70 plus? Class, the problem is that there are some people that offer physics that also offer math. They have been counted twice. There are some people that have been counted 3 times, class. For example, in this level, I say those offering math 110, raise up your hand. You raise up your. If I say those offering math 120, raise up your hand. You raise up your hand. I'll count you again, right? Those offering chemistry, raise up your hand. You raise up your hand. That's what is happening in this Venn diagram kind of question. So to be, if our class, they told you that 10 people offer physics and, pediatrics and gynecology. Class, I must inform you that this 10 is not even accurate. There's someone that offers pediatrics, gynecology, and dentistry that was counted here. When they say if you're offering pediatrics and gynecology, raise up your hand, this guy will raise up his hand. Because you are not specific. If I said those that are offering math 110 alone, raise up your hand. You said that nobody raise up their hand. Because I was more specific, right? But if I just open it to math 110, everybody will raise up their math 120, you raise up your hand. Making me counting you more than 1, 2, 3 times. That's what happens here. Class, to get those that offer PG only, because this space, where is PG? This space here is for PG. PG only is 10 minus these people are our problem. Anytime you say pediatrics only, they raise up their hand. If you're offering pediatrics, this 15, they have been counted here. If they say those offering gynecology raise up their hand, they'll be counted here again. Those offering dentistry, they'll be counted here. Then P and G, they are still counted because they are offering everything. And you do not specify. Like now, you're offering up to 8 courses. If I say those offering Mat 110, you raise up your hand. I did not say Mat 110 only. Offering Mat 130, you raise up your hand again. Chemistry, you raise up your hand. That's what's happening here. So to get the accurate number of those offering PG only is 10 minus 3, which is what? PG is 10 minus 3, which is what? 7. PG is 7. GD, those offering GD only, 8 minus 3. GD is what? 5. Where is GD? 5. PD, 6 minus 3. This is your accurate value. Now, those offering only pediatrics will be inside this box. And they are not 15. 15 is just everybody that is offering pediatrics. That's why I put it outside. To get pediatrics only, everybody that P is in their name, remove them from this 15. Although, if we look at a medical center, both 15 pediatricians, 18 gynecologists, 28 dentists. Okay. What I'm saying here, I think 15 looks more accurate. Because class, if you look at it, mathematically it's impossible to remove this 10 and this 6 and this 3 from 15. You'll be left with no, you'll have to minus people. So it means that this 15 looks accurate. It's possibly this PG that there must have been an error. So you're going to say 15 here? Yes? You see? This 7 plus 3 plus 3? 7 plus, yes, 7 plus 3. 10 plus 3 is what? 13. 15 is more than what? 15 is more than the 13. Is that what you're saying? If you have add everything where? If you add everything here, and here, plus this 15. No, you're not supposed to add everything there now. Everything here should not give you 15, no. Let me explain this to you very well. Oh, you thought that, okay, everything inside this place must give us 15? No. See what happens. Let me explain something to you. If you are doing pediatrics, 15 people are doing pediatrics. Please follow. 15 are doing what? Pediatrics. But 7 are doing pediatrics with gynecology. 3 are doing pediatrics, gynecology, and dentistry. 3 are doing pediatrics and dentistry. What would have made this thing easier for if they gave us those that are doing all? We would have known. But we are lucky in this particular question. Why they didn't bother with those details is that they're just asking for a diagram. They're asking for a what? When I teach this Venn diagram, I'll come in and actually teach you how to break down sets, Venn diagram of 3 subsets. But note that it's not a must that everybody here, when you add them up, must give 15. No. That's not how it's done. Or you're saying maybe everybody here with 15. Is that what you're trying to say, right? No. Actually, in the real sense, look up. In the real sense, 7. Oh, okay. I remember something now. Sorry, class. Class, sorry, I made a mistake. Look up. Class. To get those doing pediatrics only 15. To get those doing pediatrics only 15, I'll subtract 7 from 3 from 3. What was making it look wrong? I was trying to subtract 10 from 6 from 3. No. These numbers are not accurate. These numbers are not what? Is these numbers that we got here that are what? Everybody that has association with pediatrics is here. Those doing pediatrics and dentistry only 3. Those doing pediatrics and gynecology 7. Those doing pediatrics, gynecology, and dentistry 3. So those doing pediatrics only are, we are going to subtract this 15 from 7, 7, 3. 7 plus 3 plus 7 plus 3, 10. 10 plus 3. 15 minus 3, 13, 2. Class, this what inside there is 2. Is that what you are saying? Is that what you're trying to say? Okay, I get your point. 2, yes, 2. Now, coming to this side. You're going to subtract 18 from 7 plus 3 plus 5. 7 plus 3 plus 5 is 15, right? 18 minus 15 will give us what? 3 people are doing gynecology. Then this will subtract everybody here. You're going to have 28 minus 3 plus 3 plus 5. That's 28 minus 3 plus 3 is 6. 6 plus 5. 28 minus 11 should give you 17 students are doing dentistry only. And class, to now get your universal set, add up all the numbers because they are all accurate. They are all what? So your universal set, total number of doctors in the class is 2 plus 7, 9, 9 plus 3, 12, 12 plus 3, 15, 18, 23, 17, 40. There are 40 doctors in the hospital. There are 40 doctors in the what? In the hospital. So class, note that while we were having a wrong value before is that we were subtracting class. What I needed to do is this. I want to understand something. To get those that are doing pediatrics only, I needed to subtract everybody that has association with pediatrics. But I was using these values. These values are wrong, remember? Because some people have been counted twice in this value. I was supposed to come and use this value I've subtracted already to get it. That's what was the issue with it. This is the correct Venn diagram to that. This is the correct Venn diagram to that. What's the next question? What's the next question? Page 14. 14 number what? 3 what? 3B. 3BII. 3BI and II. Simplify each of the following and write your answers in short form. Okay. This question will take time, but do we have time? Let me take one and then we'll end it there. Let me take one, then we'll end it. So I'll take I. So you have FSD by 12 now, right? So let me do I and we'll round up. Some of you, the way you take lectures, if that is the way you give tutorial, just 2 hours. Lecture takes almost all your day. If you are the same seriousness, you give tutorials, you have been better. The way some people fear lectures, like if it's almost time for lecture, they'll be carrying their bag. I see they understand anything. But they don't understand, They'll give assignments, you will copy, but you will rush to the lecture. They'll give tests, you will copy. Please, the same seriousness you give to your lectures, give it to this class too. Give it to this. Very, very important. Very, very. So let's go to question 3BI. I'll do one, then the next one will continue tomorrow by 3 p.m. Of course, I don't still like encroaching to your lecture. You know that. So, but don't now take it more serious than the one that is making you understand. Simplify each of the following and write your answers in short form. 1 over 2 root 3 plus 1 over 2 plus root 3 plus 1 over 2 plus root 2. Class, there are 2 ways I can go about this. I can first find the LCM, or I can rationalize each of them individually first. If I rationalize 1 over 2 minus root 3, class, to rationalize a sword is to multiply both up and down by the conjugate of the sword. Follow carefully. Class, the conjugate of a sword is the opposite value of the sword. The opposite sign of the sword. Class, if a sword is 2 minus root 3, the conjugate will be 2 plus root. Why do you rationalize a sword? Class, we don't like a sword to occur as a denominator. We don't usually like our sword to occur as a what? So to prevent that, we multiply both up and down by the conjugate of the denominator. How do you get the conjugate of a sword? Just the opposite sign of the sword is the conjugate. So the conjugate of 2 minus root 3 is 2 plus root 3. But the conjugate of 2 plus root 3 is 2 minus root. And conjugate of 2 plus root 2 is what? 2 minus root 2. But class, this might be a long approach. Let me just find the LCM. 2 minus root 3 2 plus root 3, and 2 plus root. Class, this divided by this. This cancels this. What's left? This and this, right? So we have 2 plus root 3 and 2 plus root. This divided by this. This cancels this. This and this are left, right? Plus 2 minus root 3. 2 plus root. See why I said some math is one course that you find difficult to finish for the time. It's long. You can come out in the exam. Oh. Plus, this divided by this. This cancels this. What's left? This 2. 2 minus root 3 and 2 plus. What I advise students in the exam? Oh, don't start with this kind of questions. They are time wasters. They are time. Pick out the simple questions in the exam first. When you start the exam, there's no compulsion to start number 1. Pick out all the simple ones first. Now let's expand. 2 times 2. 2 times root 2. 2 root. Root 3 times 2. 2 root 3. Root 3 times root 2. Root 6. 2 times 2. 4. 2 times root 2. 2 root. Root 3 minus root 3 times 2. Minus 2 root. Minus root 3 times root 2. Minus root. 2 times 2. 2 times root 3. 2 root 3. Minus root 3 times 2. Minus 2 root. Minus root 3 times root 3. Minus 3. Minus. All over. Expand this bracket. 2 times 2. 2 times root 3. Minus root 3 times 2. Minus root 3 times root 3. Who can cancel out here? Plus root 6 minus root 6 cancel each other. 0. All the numbers that are alone. 4 plus 4. Class, follow me. 4 plus 4. 8 plus 4. 12. 12 minus 3. 9. Plus 2 root 3 minus 2 root 3 cancel each. What's left? 9. 2 root 2 plus 2 root 2. 4 root. 2 root 2 plus 2 root 2. Class, don't leave me. Oh. We're in this together, eh? Some people, your mind has left here. It's not me that said the question I'm solving. 2 root 2 plus 2 root 2. 4 root. Plus 2 root 3 cancels minus 2 root 3. So left with 9 plus 4 root 2. 9 plus is very easy to make mistake here. Anybody can make mistake here. So be very careful. I'm taking my time. How did I get 9 again? 4 plus 4, 8. 8 plus 4, 12 minus 3. Plus 2 root 3 minus 2 root 3 is 0. Minus 2 root 3 plus 2 root 3 is 0. Plus root 6 minus root 6 0. Hope I've not left anybody out. 2 root 2 plus 2 root 2, 4 root. All over. Plus 2 root 3 minus 2 root 3. 0. 4 minus 3. 1 into bracket 2 plus root. This is now 9 plus 4 root 2. All over 1 times plus 2 root 2. 2 plus 2 root. We are not still done. In short form, rationalize the denominator. Multiply both up and down by conjugate of the denominator. Class, never leave your answer in short below denominator. Rationalize it by multiplying both up and down by the conjugates. So expanding this. 9 times 2. 9 times 2 root 2 minus 18 root. Because of the minus. 4 root 2 times 2, 8 root. 4 root 2 times minus 2 root 2 minus 8 times 2. Because root 2 times root 2 is 2. 4 times minus 2 is minus 8. All over. Class, this difference of 2 squares here. 2 plus 2 root 2 times 2 minus 2 root 2 is 2 square minus 2 root 2. Or is a rule in mathematics. 2 plus 2 root 2 times 2 minus 2 root 2. You can expand it normally. You can use difference of 2 squares. 2 square minus 2 root 2 all. This gives me 18. Minus 18 root 2 plus 8 root 2 minus 10 root. Minus 8 times 2 minus 16 all over 2 square. Minus 2 square is 4. Root 2 square is 2. 4 times 2, 8. So this is 4 minus. Class 2 square, 4. Root 2 square is 2. Because square will cancel square root. So 4 times 2. 18 minus 16. 18, let me put the final answer here. Final answer here. 18 minus 16 is 2. Minus 10 root. All over 4 minus 8. Class, it's not good for a minus to be under. The minus, anytime you have a fraction, the minus is under, the minus can go up automatically and become, use minus, multiply up by minus. What will you have? Follow me, let's do it this way. It's taken as 2 all over minus 4, minus 10 all over minus 4, root 2. Minus 4 belongs to both this guy and this guy. 2 here, 1, 2 here, 2 here, 5, 2 here. So we are left with minus 1 over 2, minus 5 root 2 all over. Bringing them together now, you now have seen the adjacent denominator is minus 1, minus 5 root 2 all over 2 final. Minus 1 minus 5 root 2 all over 2 final answer. Class, every assignment you see here should make you sit up for your exam. When you see me shouting your alls, it's because of questions like this. I've seen so many exams. Different sets. It's because of questions like this. You can see this kind of question. You see? The minus down. Where did it go to? I brought it up now. I used it to minus 2. No, I did not bring it up. I expanded it. 2 divided by minus 4. All over minus 10 root 2 divided by minus 4. 2 divided by minus 4. All over minus 10 root 2 divided by minus. Oh, please follow me, please. Class, follow me. This minus should kill this minus. This minus should kill this. So my final answer should actually be plus. Should be what? Yes. This minus 4 should kill this and should have plus. Yes, this is the correct answer. Very easy to make a small mistake and you are lost. You see? Don't start with tough questions like this in the exam because you can still make one small mistake and all your effort is in vain. A small minus. I'm recording the class now. You're stopping my record. Why couldn't you call me there? So even if I'm teaching, so you just want to meet me and stop. What do you need? What level? 200 level. Wait, I'm coming. Wait. Are you Deborah? Okay, AAB pass person 200. I'm coming. Where? This, yes. Did you give you what? Yes, 2 minus root 3 times 2 plus root 3 gave us 1. Yes. Yes, 1 times this to give you this. It's the same thing now. 1 times anybody is the same. Where did these 2 come from? It's supposed to be root 2, right? Where did I put 2? Why didn't you tell me since? I was rushing. Class, this is wrong. See why it's not good to just copy. Don't just. But still thank you. I'm rushing because of your FSB class. I'm rushing. I'm not stable solving this. I'm rushing. So please, if I see any mistake, actually let me know. It's good. Yes. Actually, it's supposed to be 2 plus root 2. Where did I see 2 root 2 now? Which kind of spirit is this one now? God. Yeah, let's go. Don't worry. It's good. It's good. Another chance to understand. Another chance to. As someone seen under error. That what? 4 minus 3. Eh? Come, I'm not hearing you. There's no time. It's not good to rush mathematics, so be fast, fast. This 4. 4 plus 4, 8. 8 plus 4, 12. 12 minus 3, 9. Okay, Clara, let's move forward. Another chance to understand. Don't worry. Everything happens for a reason. Follow me. 9 times 2. 9 times minus root 2 minus 9 root. 4 root 2 times 2. Please follow me. In case please, 4 root 2 times 2. 8 root 2. Because 4 times 2, 8 root. Now 4 root 2 times minus root 2. Class, this is minus 4. Because 4 times minus is minus. Minus 4 root 2 times root 2 is what? 2. Please follow me carefully. All over this difference of 2 square. 2 plus root 2, 2 minus root 2 is difference of 2 is 2 square minus root 2, or it's called difference of 2 squares. When you have the same thing here, the same thing here, but this plus, this is just minus. You are allowed to do this. Take this one square it minus, take this guy square. It's a rule in mathematics. Now let's continue here. Equals to 18. 4 times 2, 8, right? 18 minus 8, 10 minus 9 root 2 plus 8 root 8 all over 2 square. Now root 2 all square is what? 2. 4 minus 2, 2. 10 minus 9 root 2 plus 8 root 8 divided by. So dividing everybody here by 2 cannot go. Because 9 cannot divide 2, right? 9 cannot divide 2. So this is our final answer. This is our final. Thank you for pointing that out. Very important. It's better we are correct than just to be wrong. Eh? It's an important C. It's an important, yes? 8 root 2. 4 root 2. Where did we get 8 root 8? 9 times 2, 18. 9 times minus root 2, minus 9 root 2. 4 root 2 times 2. 8 root. 4 root 2 times 2. 4 times 2, 8 root 2. Where am I putting 8 now? 8 root 2. 4 root 2 times 2. 4 times 2, 8 root. Now 4 root 2 times minus root 2. 4 times minus minus 4. Root 2 times root 2, 2. Class, minus 9 root 2 plus 8 root 2. So we have first of all 18 minus 4 times 2. 18 minus 8. 10. Now minus 9 root 2 plus 8 root 2. They have the same element. They can work. Minus 9 plus 8. Minus 1 root. All over 2 square 4. Root 2 square is 2. 4 minus 2. So we are left with 10 minus root 2 all over final. Class, is good we are doing it in class and you are seeing the process of getting the answer.